It's the final countdown for Module 2, dealing with 2.6. Form follows function. What's going on here? What's cracking? What's good with it? We're building fluency in working with linear and exponential functions in their various forms. Okay, so linear, exponential, we've worked with those for quite a bit. They're just coming back again in different ways. Sometimes they're written out as the equation, sometimes they're given a story context, sometimes we have to kind of fish and see how they're written. So we have a bunch of tools in our toolbox. We'll see how they go. Linear equations, check that out right here. We have three different ways we can talk about them. Y equals mx plus b was the first way that I thought, or that I think everybody was introduced to this, where m is our slope, b is our y-intercept. We then introduced point slope form, where here it says y minus y1, but in some of my classes, we're actually going to be writing it as y equals m x minus x1 plus y1. So this is an alternative way to write out point slope form. Standard form, A, B, and C are constants. Knowing a number of different forms for writing and graphing equations is like having a mathematical toolbox. Everybody hires you for jobs if you got a good set of tools and know what you're doing. You can select the tool you need for the job, or in this case, the form of the equation that makes the job easier. All right. So notice that with slope-intercept form, that's helpful if we know the y-intercept and the slope. Point slope form, we could take any point on the line. So it says a point, but any point that's on the line, we can throw that in, make an equation from it. That doesn't involve having to go back to the y-intercept, which sometimes we call f of 0. When we go back that far, f of 0, that's when it's occurring. Any master builder will tell you the more tools you have, the better you are. As we move into the situations, think about the important information in the problem and the conclusions that can be drawn from it. Is the function linear or exponential? This is diving into 2.3 when we first talked about those terms. Does the problem give you a slope, a point, a ratio, a y-intercept? The information helps you identify the best tools and get to work. I would agree. Those are all helpful things. All right. In his job selling vacuums, Joe, hey, Joe, makes $500 each month plus $20 for each vacuum he sells. Write the equation that describes Joe's monthly income, I, as the function of n, the number of vacuums sold. Okay. Slope-intercept form. All right. So recall slope-intercept form is going to look like this. We have y. Normally we have y. Hopefully we can get y. As y equals mx plus b, where again our slope is what's changing over time. So if we sell one vacuum cleaner, we would get $20. If we sell two, we get 40. So I think the thing that's changing here is the 20. So I'm going to write in 20 as my slope. And then how about the y-intercept? What are we no matter what going to have? Hopefully you're saying 500. If we graph this out, this would look like this, starting at $500 at the very beginning after selling one vacuum. I won't draw graphs for all of these, but I think this first one's good. This will be money made. Every time we sell a vacuum, we go up $20, and that's going to keep on going. So just like that. So this is our equation. This is a quick sketch of the graph, so on and so forth. Makes sense to me. Let's see what's up with the next bit. Write the equation of the line with the slope of -1. Ooh, they're giving us information right now. So they're saying our slope is -1, and we're given a point -2, 5, We're using point slope form to talk about it. Okay, so I'm going to label this x1, y1. For those students that maybe misplaced their packet, remember point slope form can look like this. All right, so then if we throw this all in, our slope's given, -1. We have our x coordinate. We're subtracting -2. That looks ugly. We'll change it shortly. +5 is round the outside, round the outside. -1's up in there. Subtracting this -2 should make it x plus 2. Add on that 5 at the end. Points noticeable. Slope's noticeable. Boom, point slope form. Done. Keep that momentum going. Explicit equation of the geometric sequence with a constant ratio of 5 and a first term of -3. All right, so recall, if it's a geometric sequence, this is going to be going exponentially, right? So we need an exponential equation. So recall that when we write those out, we can say that A is our initial value. Our B term in parentheses is our constant ratio. And then usually X is up just at the top, and that's it, okay? This one's pretty simple. First term is -3. In parentheses, we want 5, and this occurs X times. We'll put in f of X equals this. Call it a day on this one. Cool. So notice the first few are just you setting up the equation. It's not so much graph everything. Setting up the equation is such a big pivotal thing that we did in this whole module. Write the equation in the function graphed below. I know this is a straight line, so it's definitely going to be linear. Name the form of the equation you wrote and why you chose that form. All right, well, we have to make this equation based off of the graph. I know that this is linear, so I'm assuming it's going to take on y equals mx plus b form with our y-intercept of -3. So this is -3 towards the end. What else do we need? We need a slope. So let's fish for that. Let's see. I see another point right here. I see another pretty easy to spot point right here. So it looks as if we have something going on. Every 4 units, we go up 3. But let's map out that slope. 1, 2, 3, 4. Our run in this case is +4. Our rise is 1, 2, 3. That's positive. Recall that our slope, so rise over run, our rise was 3. We put that over the 4. This is our equation. 3/4 x minus 3. I chose to use this form because 1, it's linear, so that usually takes on y equals mx plus b. I had my y-intercept that was noticeable, so that's what I held on to. You could have also used point slope form, so that's another option, but I thought this was easy because I had my y-intercept and getting the slope was pretty simple. Cool. Let's keep it going one more time. Population of the resort town of Java Springs in 2003 was estimated to be 35,000 people. I'm going to put that in right then and there, boom, with an annual rate of increase of about 2.4%. All right, so we're using the table to talk about how this increases. Well, I know that since this is an increase of 2.4%, it's as if I'm taking the normal 100% and I'm adding 2.4%. So really, I'm taking my previous, and I'll actually put this in words because that's a throwback. I'm taking the previous, multiplying it with 1. Well, how do you think this would look? 0 to 4. Kind of a crazy decimal there, but nothing we can't handle. And that should be equal to the current. Again, I'm getting this based off of the fact that it's the increase. So I want to throw in the 2.4%. And again, I'm achieving the 1.024 by taking my decimal and throwing it to the left once, twice, putting it there, scratching this out, and that's how I'm getting the 1.024. All right. So how this is going to keep going, I know it's going to be exponential because I'm using multiplication. As far as filling in this table, I'm taking the previous, multiplying it with 1.024, and this normally gives the outcome. I would then take, well, fine. All right, I'll get it. I'll do work. That's fine. So what's 35,000 times 1.024? 35,840. If I take that and multiply it again with 1.024, 36,700.2. I can take that one more time, multiplying with 1.024. You got the idea, right? It's going to keep going up like Tuesday. 37,580 point, let's round up to the 1. Yeah, 37,581. So that'll keep going. What's the equation? Well, our starting term was 35,000. Kept multiplying it with 1.024, and I kept doing that t times. So it's exponential because it keeps multiplying. The equation, again, is using our starting term, which was 35,000, keeps multiplying with 1.024, and that occurs t times. Jessica's science fair project involved growing some seeds to see what fertilizer made the seeds grow fastest. One idea she had was to use an energy drink to fertilize the plant. She thought that if they make people perky, they might have the same effect on plants. This is the data that shows the growth of the seed each week of the project. All right. Well, now we have a table. So immediately I'm going to think out what's the change from here to here, and is that consistent? So this is definitely adding 1.2. Is this also adding 1.2? Sure is. Sure is here. Okay, so it just keeps on adding 1.2 every time we add a week. So that's nice. What's the equation that models the growth of the plants over time? Well, you have a few options. What I'm going to show here is getting y equals mx plus b. What I'm going to show here is using point slope. Both of these are going to give us the same outcome. It's up to you to which one you think you like better. If I was going for the y equals mx plus b form, I would need my 0 term, which would involve backtracking 1.2, which would make this 0.5. So this is adding on 0.5 for the 0 term. And then I keep adding 1.2 x times. So that's one way you could approach it. That being said, you could also throw in the slope of 1.2, parentheses x. You could use any of these points, honestly. You could do x minus 1 plus 1.7. That would work. You could also use I'll only show 2 more of these. You could also use, no, it's not that. It's 1.2. All right, 1.2, x minus 2, because again, it's 2 units away from 0. And then plus 2.9, feeling fine. Another option, you can keep going with these if you want. I think it's pretty good practice, honestly. X minus 3 plus 4.1. So lo and behold, we actually have several ways we could talk about this line. Count them: 1, 2, 3, 4. They all work. If you're not convinced, try them out. Keep it going. What do you know about the equation based off of that? I know that this gives us the y-intercept and slope. So really, it's giving us a point and a slope for the line. We actually have to graph this. All right, y-intercept's -5. This is going over 2 units and then up 1. And I'll actually show that change. So again, I started at -5. I went over 2, up 1. Because again, it's a positive slope, so I know it has to go up and to the right. I'll conclude this line so that you don't think I forgot about it and got lazy. I'm worth it. All right, boom. What do you know from the equation that helps you graph the function? I know that this is a few things. I know that this is exponential. I know that, well, I don't know, it doesn't have parentheses. Like normally we have a times b to the x, but this just has 2 to the n. What's normally right here? It's normally our starting value, but in this case, it's not written, but we can assume it's just 1. So that might be something interesting to mention. Is that we're working with an exponential function starting at 1. We keep multiplying by 2 n number of times. This is going to have an arch shape to it when it's graphed out. Our common ratio is 2. Pretty cool. All right. If we want to graph this out, get a little table going, or you could, think of what I said. I said that our starting value was 2, and then we keep multiplying. Sorry, starting value was 1, and we keep multiplying that by 2. So that goes to 2. Then it goes to 4, to 8. And it just keeps going up like Tuesday. And if you wanted to see how it keeps going back here, it would go smaller and smaller and smaller. But that's a pretty good setup. What else? What do I know? I know that this is in point slope form. I can get a hold of a point on the line. I can get a hold of the slope for the line. I know that it's linear. I know that it could be rewritten to slope intercept form. And I know it's going to have a straight line, right? So just based off of this, I'm able to actually say a lot. I'm able to say that I have my slope as -2, and one point that I know is on the line is going to be -6, because again, we take the opposite of the x term. Does that make sense? And then in this case, they have y1 over to the side, so that y term's just 8. But if you wanted to, you could have rewritten it so that you had 8 on the other side. So if you wanted to do that, you could have y equals -2, x plus 6, plus 8. Lo and behold, +8, +8. Nothing wrong with that. All right, let's graph this thing out. I'm going to use that point, -6, 8. That's over 6 of 8. So right here, going with our slope of -2, we can go over 1, down 2. So over 1, down 2. over 1 down 2, over 1 down 2. I personally always keep my run positive because I want to move from left to right. All right, let's map a line because I'm getting lazy. I don't feel like mapping out all those points. I really could have just done this with 2 points, but I gave you some more because you're the best. You're just the best. Everything that I can give to you, I can. So there you go. That's what it would look like. What else? This seems like a big just review section if I ever saw it. I know that this is a recursive function. And I know that I have a starting term starting at -5. I'm going to talk about this in words. Starting at -5, we keep adding 1. We could eventually put this into an explicit, so it can be written as an explicit. I know that it is linear because we just keep adding 1. And it's a straight line when graphed out. All right. So I'm going to actually show a table for this also, because if you're not convinced this is linear, I'll show you. So let's say that we have n terms measured against f of n terms. Our first term here is -5. And I know that as this keeps moving forward, it's going to be adding 1. So -5 plus 1 gets you -4. Keep that momentum going. Oh, you could actually backtrack too. How about them apples? And this is still giving respect to the fact that you're adding 1 as you move forward, but in this case, subtracting 1 to get -6. So this one is going to be pretty easy to graph out. All right, so we're starting at -6, and we just keep adding 1. That's it. So just let me make sure this is lined up, crushing through everything. Looks good to me. So I had the option again to just start with when x is 1, the outcome's -5, but I took it further. If you're curious about what the linear line would look like, I don't know. What do you think it would look like? Hopefully you're saying it would be y equals -6 plus 1x. There you go. A lot of information on that one. Nothing you can't handle though. Takeaways. This section is reviewing a lot. So remember, on the very first slide, there's so much important stuff that's here. That's really important. Linear can be written in slope-intercept form or point-slope form. Standard form, we didn't see too much. Also be mindful of exponential functions. I know they're not mentioned here, but I mentioned them on one of the pages. So if you have any questions, reach out. I hope that this was helpful, and I hope you have a great day.